Alright guys, welcome to the second stream on my channel. Essentially today we're going to be going over a few things. First of all, the Audi TTRS. I'm helping a client of mine with the 8J TTRS be able to get over 255 kPa of boost. And one of the things that is difficult with tuning this particular platform is the fact that this car can only read 1.55 bar of positive boost pressure because within the ECU there is the boost pressure variable is actually only 8-bit, meaning that the resolution of the boost pressure can only go up to 1.55 bar or 255 kPa. So if you go to a calculator and you convert hex to FF, right? So we've got FF. If we convert that to a decimal value, the maximum that can be is 255. So anything above 255 cannot be stored in that variable, unfortunately. So one of the things we have to pretty much do is we have to turn off some of the monitoring systems that will allow it to go over that sort of boost pressure, okay? So there are a few things that we got to do. First of all, there are some ratio factors that are for the monitoring of boost pressure. We need to limit those and disable those in order to achieve that level of boost pressure on this car. That does mean, yes, that technically it won't work within a closed loop boost pressure control system. However, this particular ECU and car is on a very big turbocharger. So for the fact of the matter is here that it'll be open loop anyway based on pedal position and engine speed. So there's no closed loop control system for this car. Essentially, we'll be reading the boost pressure externally and the ECU won't be doing any of the boost pressure control. But we just need to make sure that we're allowing it to go over the internal 8-bit variable limit of 255 kPa so that we can actually have some full power and everything. So nevertheless, we're going to get straight into it. So a few of the things that we can do, again, we've got our definition file on the left-hand side. We've got the file we're working with on the right-hand side. And I'm going to start going through all of the maps and parameters that I need to transfer to the right-hand side to then calibrate the file. Obviously, being in German, right, because it's a German car, it's an Audi TTRS, it's made in Germany. The software was designed and made in Germany as well, so it's all defined in German. So as a result, a lot of the things we have to look for, such as boost or pressure, is Druck, which is the German word for pressure. And the idea is to go through the maps and look at the parameters that we need, and then search for them between the two files, right? So the way that I search for it is I select a bit of data here on the left, and then I can match it up with the window on the right-hand side. So if I offset these, you'll notice how it's color schemed in red and blue and then green for where it matches. So green gives us an indication that data is matching between the two software versions on the left and right-hand side. Red means it's a higher value than the opposing matched software, and then blue means it's a lower value. So if I'm going to go ahead and search for it, I can just select a bit of data. WinOLS can then go ahead and find that in the right-hand side, and then I can go ahead and do what I need to do with it here. So the idea is, like I said before, I'm going to find a few of the maps that I need, the minimum and maximum tolerances for pressure before the throttle. And then I'm just going to go ahead and search through a few more maps that are going to allow us to achieve this lack of throttle closure, I suppose you could say. Morning coffee. And you'll see here, essentially I'm looking for these sorts of things, right? Like max and minimum voltage and pressure variables around the throttle plate, yeah? So back to pulsations. Minimum, maximum for diagnosis. Actually, that's probably a good point. I should look at that a little bit more. We've got our PID maps. So this is the steady state. Oh no, this is not steady state. This is the limitation for the wastegate controller, but we won't be needing this particular map because we're running an open loop. for this particular car. We're going to be going through a few of these here, having a look at everything. What I might actually end up doing is typing in diag, okay, open all folders to have a look through them all and see some of the things we need. See here we go, right? So there's a code word for the diagnosis of the boost pressure regulation. So I'm probably going to disable that. Like I said, the only reason I'm doing that is because of the fact we're running an open loop, and I don't want there to be any throttle closure when we run over the map sensor limit, which is 200, no, not map sensor limit, sorry, the internal 8-bit variable limit, which is 255 kPa. The reason why an 8-bit variable has that limit is because the maximum value that an 8-bit variable can be in hex is FF, which in decimal is 255, right? That's 255 kPa or 1.55 bar of boost positive pressure. So that's why any boost above that for this particular car, you need to kind of run it in an open loop because you'll get throttle closure, and then coupled with that, you need to disable the regulation of the boost pressure. So that's why we're doing that. I don't recommend disabling these sorts of things on obviously on your stage 1, your stage 2 cars, but when it comes to other vehicles like this, which are a very unique setup and require this sort of programming, then yeah, that's when, you know, it's all good to go ahead and do those sorts of things. Cool. That's definitely the one there. That is the ambient pressure sensor. That's the boost pressure sensor. Let's have a look. So we go DK, diag. DK is the throttle plate. Okay, Drosselklappe. That's what it stands for. Let's see if there's anything we need. I know that with a lot of Bosch software versions, there are the maps that we need to tune near the airflow map for the throttle plate and also the throttle plate itself. So if I go ahead and search left and right here, usually they'll be around here somewhere. Yeah, see maximum tolerance for mass airflow. Okay. Sometimes there'll be some other ones too which we need. And this is the thing, it just requires someone to go through it with a fine-tooth comb and find all the relevant maps that we need to be able to make these sorts of changes, right? Maximum tolerance for intake air. Okay. Getting there. Alright, let's try and start with that and see how we go, okay? Alright, so maximum tolerance of air, maximum factor, I think 2 makes that FF. Maximum under tolerance of pressure, maximum upper tolerance. I'm probably going to set that to 2 bar. Like I said, I've already explained why I'm doing this. It's not to turn off any safety systems. It's more for the fact that we need to get above that 255 kPa internal 8-bit variable limit. Now with these here, right, if you're not sure what these things mean, you can go through some documentation. If I go to VAG and then I go to something like this, okay, and let's say we want to go to ADSM module. So we go down ADSM, and I'm going to go ahead and copy this code word. I'm going to search for the code word in the manual. Okay, and in here, so BLDRA, I'm guessing that is to do with the diagnosis of the boost pressure regulation, right? It might be within my best interest to turn this off. Okay, let's have a look. We can with translate, just to make sure that I'm not making any silly changes. Cool, okay, Perfect. Let's just go ahead and turn that off. And there's another word. Is that the one that we need? CWD LDR. Cool. CWD LDR. Cool. And then we've also got this one here, which I might just go ahead and search this first. Switch on condition of the LDR, so the boost pressure controller, the regulation. I'm going to copy this, go to that particular module now, which is BBLDR side. And I'm going to, so there we go. Cool. Okay. Perfect. Right. It's probably a good thing to go ahead and read all this so we can understand how the module works before we start turning off control systems or manipulating control systems. Okay. Right. So that's pretty important. Okay. So this all in here is the configuration of the closure of the throttle plate, which is pretty good because this is exactly what we were looking for, right? So I'm going to look through here and try and find any relevant throttle plate variables. So we've got, here we go, BPVD, LDR. Let's have a look. It's important to kind of go through and find out what these different variables mean. The way we do that is we pretty much search for them. Here we go. Boost pressure active. Something for the boost pressure regulation adaptation. Here we go. This might be good for us to look at, right? Different code words. Limitation, there we diverter valve error. So bit 2, we can turn that off. But that's already off anyway. I think we'll leave that one. Okay, let's go boost 255 kPa adjustment. Right, there might be a few other things that we need to change. Have a look. Okay, let's start with that. Cool, so that's our first file today, and we will give that to our friend. And we now need to start working on the Volkswagen Amarok that I was doing. So I'm doing a multi-map project for the Amarok. So I'll open up that now. And you guys can sort of see how I write the multi-map code. It's pretty interesting. It took bloody a long time, let me tell you. Like, it took a very long time to learn this stuff. Well, I started in like 2017, I think, Amarok, learning all this. So essentially the first thing that you do when you're learning with Multimap or learning to write Multimap, after you've understood the foundations of the assembly language or C, whatever you're writing it in, I like to just find the variables that I need to work with, such as the engine speed that's sent to the cluster, and I will try and find the reference to that, such as here, right? And I'll disable it. So I'll just NOP the operation, meaning that in assembly language it kind of skips over that line, or it doesn't do anything. And then I delete the entire, I guess, the storing of a value in that variable that's then sent over the L line or the CAN or whatever it may be to the cluster that tells the cluster what engine speed the car is at, right? Because I want to hack into this or hook into this variable and manipulate it depending on what map we're in and based on a series of inputs, such as those from the cruise control stalk, okay? So for me, once we've got that, we can then create a call or a branch, however you like to say it, and we can basically jump to our code, which will then execute and manipulate the cluster based on our inputs, which will be usually the brake pedal and the cruise control stalk for me. That's how my sort of strategy works. A lot of people do it in different ways. That's how I do it, and I like it being able to be done without having to wait. You know, like a lot of people say you have to hold the stalk up for like 3 seconds and then it enters multi-map mode. I just kind of like being able to change it pretty much instantly. So brake pedal and then an actuation of the cruise stalk, and then that's fine. All right, cool. So I'm going to go to this address. Okay, this is the storing of the value of our engine speed into the engine speed variable for the cluster. So what I'm going to do here, essentially, is I'm going to create a call here that sort of takes over these two instructions, right? And it'll jump to an area of code which is free, where nothing is happening, so there's nothing being executed. An example of that, if I go down to like here where it's 0, right, I can actually patch in a bit of code here and where it's not doing anything. And let's say we want to understand where the engine speed to the cluster variable comes from, or you can see on the right hand side where I've already defined it all, we have the engine speed high resolution, right, that's being loaded, and then it's loaded into a data register, and then it's being stored into this variable here, which then gets sent, like I said, to the cluster. So I can go ahead and start defining things on the left hand side just to make it easier for myself. But yeah, you get the gist of it. So what I might do, I might go to a address which I believe to be like a whole, you know, a round number, let's say, or a round sort of address, like let's say here, right? So we've got, boom. Okay, so 3CA A000. I'm going to select a region of free space. I'm going to press K. That's going to then define it as a map. Obviously, it's not going to be a map. It's actually going to be my patch. And I'm going to call this patch cluster. Okay. And that's now a map that's in my WinOLS pack on the left-hand side. You can see here, right? If I go move into Ghdira 1, Multimap. Okay. You can see here, we've got our multi-map folder with all of the different maps that I've created for my own various reasons, but this is where the patch is going to be. So I'm going to copy that address, and I'm actually going to go to that address in Ghdira. So it'll be something like that. I'm going to label it. I'm going to call it multimap underscore cluster. Okay, and I'm going to bookmark that as multimap category, and then as cluster there, so I can get back to it if I need to. So if I'm playing around in some other bit of code, I can just click back on multimap cluster and it takes me right back to where I need to be. Okay, so from here, what we are looking to do is we're looking to pretty much create or load the preconditions. The first one, now it depends whether you want the person to be able to switch whether or not the engine is running or not. A lot of people have the precondition that the engine has to be off in order for the multi-map function to work. That's great, but it can be pretty annoying. Like if you just want to switch maps on the fly, you kind of have to turn the engine off, you have to turn the ignition on to position 2, and then you have to start doing the switching from there. But I prefer it to be done anytime on the fly. So if you have a look at my other videos, you know, the engine's running, I can create conditions where the vehicle speed has to be 0 and things like that, so people shouldn't be switching things while they're driving and then have an accident. It just depends on the application, depends on the car, depends on the client, whether or not I trust them and their ability to drive. But nevertheless, first thing I'm going to do is check for the brake pedal being pressed, okay? So what I'm going to do essentially is go to a read, and I'm going to load the byte for the brake, okay? And I'm going to put it into our Multimap cluster here. So load byte unsigned. Unsigned meaning that it doesn't have negative values. Unsigned, it means it's just positive only, okay? And essentially within this address here, there's actually more than just the brake pedal. It's actually quite a few things, if I can try and find it on the left-hand side. But you'll often see that there can be up to 8 different variables that are stored within an address. And that's because if you think about it, a binary number holds 8 different bits of data, right? Now, each of these different bits can actually be different switches for different conditions. And if we want to maximize the amount of space and memory that we have in a computer or processor, it would be wise, especially for Boolean statements which are on or off, true or false, it's a good idea to store them within a bit, within a byte, right? So you can have multiple different conditions or multiple different switches within one particular address because there is 8 bits within that address, right? And the way that I can represent that to you is if I go here and I've got it in hex view right now, if I change it to binary, you'll see that it's 0, right? But if I can do this, right? And you can see that every single address within here, or every single byte, has a maximum value of FF, or 0 to FF, and in binary that's represented by a row of 8 ones, okay? Bit 0 starting on the right and all the way to bit 7 on the left. But that's how these sorts of things are stored in the processor, okay? So you have the brake pedal being stored there. I'm also going to open up ASAP. Or I might just search for it. No, I'm not going to do that. I'm actually going to do it this way. And if I go to Volkswagen, I go to CP54 or just Amarok. I then bring that in. And then we're going to go to the search bar. We're going to type in this variable that we're after, and we're going to see here that the bit mask is 10. Okay, a bit mask of 10 is a bit position of 1, 2, 4, 8, 10, bit position of 4. Okay, I'll explain that to you. So essentially, if we go notepad, hopefully there's nothing there. Cool, don't save. All right, so let's say we've got a bit, these are our bit masks, right? Bit masks. And then we have our bit position, right? So if I have a bit mask of 0.1, 0.2, 0.4, 0.8, 0, 10, 20, 40, 80. That's it, okay? Now, this translates to a bit position of 0. This translates to a bit position of 1, 2, 3, 4, 5, 6, 7. So we have our bit position on the right, we have our bit mask on the left, and that's how the processor will often reference the location within a byte, so which bit it is, based on something called a bit mask. Okay, and you can look up what bit mask is on Google or ChatGPT, whatever it is that you need to do. But in order to find out this particular variable, which is the status of activating the brake, right? It is a bit mask 0 times 10, which is a bit position of 4 at this address. So if I then go to this address in Ghdira, where I've already defined it, right? It's got here, so I'm going to just save that there. I might actually label that as bit position 4, which I do by doing something like that. Okay, so then I know that at bit position 4, we have the brake, right? So now what I got to do is I got to go through the references and find out where, see this? We're manipulating position 4, right? So here's a great example of that. I found it in the right-hand side. I'm going to copy that address into WinOLS, and then I'm going to try and search for that similarity because the code essentially is the same, right? They're both Amaroks, they both have the DDXC engine. So a lot of the processor information, processor code is going to be the same. The addresses at which they're referencing might be different, but the data that's at those addresses will be very similar or the same, okay? That means that maybe with some particular cases, some of the bit positions are different. So we'll just have a look at this together. And we can see here that bit position 4 is the brake pedal on this software version, but bit position 0 is the brake pedal for the software version that we're working with. So what I'm going to do is I'm going to label that 0, okay, so that we know that at bit position 0 we have our brake pedal, okay? And so what we can do now is we can go back to the cluster and we can go jump 0.t, which is jump 0 depending if the bit at whatever position I specify is 0. So we're going to go bit position 0 because that's what and we're going to go to whatever address we're going to jump to. I'm just going to say 803C9FF0 as an example. And it's going to jump up there, which may be our multi-map exit strategy. Okay, so if the brake isn't active, exit the multi-map functionality because that's one of the preconditions in order for us to do the switching. In which case, what we're going to do is we're going to set all of a few other conditions to 0, such as our latch variables, and we're going to set the engine speed to the cluster to be what it was when we hooked into this function, right? And that's pretty much that, okay? So now we're going to be checking for our cruise control functionality or the cruise control being active. That's the next thing we're going to have a look at. So I know that, for instance, we have our cruise control at this address, okay? And if I go to it here, maybe I've kept it. I have. Okay, and we can see here that we've got our cruise control bits. 20 ms is the raster or the time at which this particular function cycles, or the function that these variables are contained within cycles. So it's 20 milliseconds. Okay, and then we have the different variables which they are. So we've got our tip up, we've got our tip up set, we've got our tip down. So I'm really looking for tip up and tip down in order for us to actually manipulate the cluster. And then also I'm going to be looking at the cruise control pull. So if I go to Amarok 3-litre TDI cruise control stalk, okay, we have a look in here, we can see that that's pretty much what it's going to look like from what I know, you know. There we go, there's one right there. So that's what our cruise control stalk looks like. So that I know how does the ergonomics of this particular code that I'm injecting work. Which buttons does the customer need to press? Does it make sense? Because obviously I know, like with Ferrari 458s or 488s, their cruise is on like a little dial, and it's not really ergonomic to switch maps like that. It might make more sense to, with the engine off, hold the brake pedal and tap the accelerator to like switch between different tunes. This seems okay, like to hold the brake and to press res to go up and set to go down, right? That makes sense to me in order, you know, to pretty much change the different tunes that we're going to be working with. So I'm going to do it that way. And what we're going to do is we're going to find out which bit mask each of these different variables is at, right? Our tip up and tip down. So our tip up, we're going to go ahead and look at the A2L. And we're going to see that's a bit mask of 20. Okay, now if I go back to what I was saying here before, bit mask of 20 is a bit position of 5. So as before, I'm going to change the label. I'm going to add 5 at the end of that, just so I know that's a bit position 5. And then for the tip down, I'm going to do the same thing. I'm going to have a look at tip down, and that's bit mask of 2. Okay, if we go back to here, bit mask of 2 is a bit position of 1. So same thing here, label, change that to 1 there, and we can see now that if we go through our XREFs, we'll go to where we are manipulating this, okay. It might be difficult for us because, as you can see, we're just loading the byte. We're not actually immediately doing a jump with the bit position after it. But if we have a look here, D15, okay, jump not 0, that's 5, so that, let's have a look and see what's going on here. So if I go to this address, remember, in WinOLS, is that the right address? It probably isn't because of the offset of the file. So I'm going to copy that code, search for it there, and there it is. And it's pretty much the same. Like, I'm going to say it's the same. Let's just start with that because that might make it easy for us. And obviously if it's not, I can do what I need to do to change it. But as you can see, that is going to work pretty good for us. Okay, so what I'm going to do, I'm going to go back to our multi-map cluster. I'm going to go mov h.a, A15, and then 0 times, what is our, it's B000. Okay, and then I'm going to go LEA, A15, A15, and then plus the offset, which is going to be 5C65. Okay, and then I'm going to go load byte unsigned, D15, and then load A15 into that. Okay, and as you can see, that is loading the address in RAM of the cruise control stalk tip up, tip down into data register 15. It's an unsigned byte because it cannot be a negative value. A negative value might be something like a pressure variable where we have negative and positive pressure. Obviously for a multi-conditionary bit or binary value, we don't need negative. There's no need to have negative for a true or false statement. It's just on or off, 0 or 1. Okay. So we're going to load that into data register 15, and then from here we're going to start checking some conditions. Okay, we're going to check whether the cruise control stalk is being tipped up and tipped down. Okay, so we're going to go ahead and check position 1 and check position 5. So I'm going to go jump 0.t bit position 5, and then I'm going to jump to a certain address where we're going to be doing some passing of hold on, 03, let's have a look, CA0402413. Okay, that's not liking us. 803 CA024. Oh, I know why. Forgot the 0 at the front of it. Cool. So we're going to jump there if our, and that can be our tip up, right? Or if we have a look at the cruise control lever, that's our res plus. Okay, so res plus. Okay, and then we're going to go jump 0.tg15 and then bit position of 1, 803 CA 0 maybe 60, and that's our set minus. Okay, you see how that works? And once we've checked that, we might want to also have a look at our latch variable. So a latch variable basically is where when you enter some function, the latch turns on, and that keeps you contained within the function. When the latch is off, it jumps you out of the function. And an example of that is, let's say we've hit the brake pedal, we hit the tip up, it jumps to map 3 or map 2, whatever you're at. We want it to continue to show what map we're at so long as the brake is held. That's called a latch variable. When we take our foot off the brake, the latch variable goes to 0. It jumps us out of that bit of code or that function, and then the engine speed variable to the cluster is received from the engine speed variable that's derived from the crank and camshaft speed sensors and things like that. Okay, so yeah. So once we've checked that, I like to check the latch variable, and we'll do that now. So my latch variable is stored at this address. Okay, so what I'm going to try and do is I'm going to basically try and go load byte unsigned, or actually, no, yeah, I'm going to load byte unsigned D15, and then I'm going to try and do that. If it doesn't work and it doesn't let me load it directly like that, we're going to have to do the mov high and the load effective address. Right, so mov high, we're going to do, what's going on, mov h, there we go, A15, and then we're going to 0 times is it D001? Okay, we're going to go load effective address A15, and then we're going to go A15 with a offset of 5A2F. Okay, load byte unsigned, D15 of A15, and you'll see that's our latch variable there, where I've defined it anyway. So that's a mov high. Okay, what that means is within, again, a byte, within any sort of address, we have, for this particular case anyway, mov high, what it does is it sets the value that we're loading high to the leftmost bits, right? The left 4 bits there, or bytes rather. Okay, so there's 8 bytes because I believe it to be a word. Okay, when we're moving it high, we're moving the address value of the word high, and then that means when we load effective address, it actually adds it on to the right hand side. So when we mov high D001, it puts it there. Loading effective address of that makes it 5A2F, like that. So that's the complete total address, and that's what that means, right? And then we're loading the byte from that particular address. So whatever is stored at that address, we're loading it into a data register so that then we can perform some arithmetic operation or Boolean operation based off that. Okay, so our latch variable is there, fantastic. Now we're going to basically jump 0 or jump not 0. We might actually jump if it's 0, D15. And then where we're going to jump to, we might just go 80, the multimap exit actually. We can just type in multimap exit. So it jumps up here, okay? And that's great. If the latch variable is on, then we have to actually continue to show what RPM the cluster's at. So we might go and put that somewhere down here, like let's say just this address, and we might go jump to that address, okay? And that's going to be the show, it's going to be show map at that particular address, all right? And then if I go, I just run a comment, latch off, okay? Or maybe jump if latch off, jump if latch off. It's also good convention to comment your code. When I did go to university before finishing, I was told to comment code. It's good to comment code. So you might do something like function information. You might go purpose, and you might go to manipulate the cluster in alignment with current map. Okay. Also to select different maps on the fly. Okay. We might go inputs, and we might go, well, really, we're not really taking in any inputs like into the function. Outputs, we're going to be outputting the engine speed cluster, which is, what's that? That's n disp optim and VW. Okay, and then we might just do something like author, and then Josh forward, and then date if we want to, right? So I go 08 10 2024. Now that's good to do, especially if, let's say, we are writing this code for a company and we're selling the source code to them. It might be good just to do things like that. It helps the person who obviously does the things internally within their business understand your thought processes, and helps them understand how you've done things. It's also important to comment and label things as well, like instead of just having, because I know a lot of programmers, they do, and I get it, it's efficient, I get it, right? They might, instead of having multimap exit, they might go ME, right? But what's ME mean? Like, no one actually knows what it means, right? Like, multimap exit to me just means it's easier. This usually is the case for when they're like defining variables. You know what I mean? Hold on, I'm just going to save this as multimap Amarok V1. I'm going to do .bbc. And, you know, so if I go like to the C, it's going to compile into C code on the right hand side. You'll see here the A8 and things like that. So these are the names. And these are the names here as well. And then see, you've got BVAR1, right? Like, cool. It's got the name BVAR1, but call it something a little bit more meaningful. You know what I mean? That's just my opinion anyway. Cool. So that's done. So we've got our enter the function. Brake pedal needs to be active. Cruise control bits are checked. If they aren't checked, then we have the latch bar being checked. If the latch bar is off, we exit the function, and otherwise we continue to show the map. Now, what I'm going to do, I'm actually going to jump to here, right? And I'm going to actually just call this tip up. Okay? And from here, I'm going to basically check our, not our latch bar, but our cruise latch bar. Okay. H.A. Okay, so this is to check to make sure that we're not holding the cruise control stalk up, because the raster or the passing time is 20 milliseconds. I doubt very much that you can cycle the cruise control stalk within 20 milliseconds. Like, what that means is that when you're trying to switch map, if you haven't got a cruise latch, it means that every time you press it, it may have cycled the function 3 or 4 times, and then you've gone from map 1 to map 1 again because it's gone all the way around because of the fact that it's cycled this function every 20 millisecond period. So having a latch bar means that it won't allow it to cycle this particular part of the function until you let go. So it only allows for 1 cycle per button press, okay? And that's why it's important to have latch bars. Anyway, load effective address again. And then we've got our cruise latch bar, so that's A31, okay? And then we're going to go load byte unsigned, D15, A15, okay? And you can see here, there's our cruise latch bar. Now, if that is indeed to be, if that's jump not 0, then basically we want to jump to that address there, okay? So if it's not 0, meaning the cruise latch is still on, we want to make it 0. Now what I'm going to do, I'm going to go then, if it is 0, we then want to make it 1 because we've now pressed the button. Okay, so mov 1, okay, and then we're going to go store byte D15, A15, D15. Okay, does that make sense? So we're checking if it's on. If the latch is not on, if the latch is on, we're then going to go ahead and continue to show what the current map is because we're still pressing the button whilst it's going through the 20 millisecond cycle of this function check. Okay, if we're not pressing it, then it's going to go and enter the function, move the value of 1 into data register 15, and then set the cruise latch on. Okay, that's going to make sure that when we come in again to this function, it's not going to continue to change the map. Okay, and that needs to be true for every single, I guess, tip up and tip down, right? So now that that's done, we're going to check the value of our map, state, or our, what do I call it? Map switch map, I suppose. Mov h.a. And then we're going to go ahead and load it in again. A15, LEA, except this map is stored at 30. Okay, we're going to go load byte unsigned, D15, A15. This is going to load our map switch map. So our current map, I might actually just change that value, but it doesn't really matter that much, to be honest. Okay, a map switch map, and then we're going to jump if equals D15. You see here 0 times 0, and then we're going to go maybe 803CA070 or 3 803CA. Another thing as well with Tricore, with the jump equals operations, it needs to be 8 bytes. It can't be 4 bytes because that's just the way that, from what I understand, these processes pass things. If you're doing a jump equals statement, it has to be 8 bytes. So you can see here, right, if I go back and change this, it gives me the option to write this opcode or this instruction as 9E07. This process will actually corrupt itself, and you'll brick the ECU if you do that with 4 bytes. So 8 bytes is what's necessary for this particular operation. So that is our map 0. Oh shit, I'm going to change that to end of line comment. Okay, we're going to go jump equals D15 if it's 1. I'm just going to make them all go to the same place for now, just before I... okay, jump equals D15 0.2. Okay, and then we're going to basically go from... so that's map 1, map 2, map 3, and then we'll jump to map 4. Actually, we'll do jump equals just to make it look nicer. 0.3. Boom. Okay. Cool. So that's tip up. Now we're gonna put tip down here. So we go down, tip down, tip down. Okay. We're gonna pretty much copy all of this code. I'm gonna put it in here. Okay. Obviously, where we're jumping to, we're gonna need to change that, but it's another thing. Cool, where's this coming from? So that is our show map. That's fine, we can do that. So if we go, we make show map here. So show map, show current map. Okay, and we're going to do that. Oh, shit. Show current map, and we're going to go show current map there as well. Okay, it's looking pretty good. Making a lot of sense. I'm going to save it. Okay, if we can look at actually how the graph flows as well. See this? So this is the graphical representation of our program flow. If some people like to look at things like this, that they understand it better. I very rarely use that, to be honest with you. Or if you want to have a look at it in C again, you can press this C compiler up here, and it'll give us the code in C, or at least what it thinks it looks like. I would disagree as to that's what it looks like right now, but maybe it's because I haven't finished the function properly. And yeah, so what we're going to do, show current map. We're going to load in our map switch variable here. Okay, I'm just going to do this quickly so I know what I'm doing. Okay, I'm going to load our current map, and then we're going to have to create some jump equals again. So we're going to take up 1, 2, 3, 4. So we're probably going to jump to here. Okay, jump equals D15, 0 times 0, and then we're going to jump there. Okay, I don't know how much data or space this is going to take up, right, to do this. I'm going to jump here. We're going to, I'm just going to go back to, where is it? Our optimum reference. I just want to check. Okay, so D15 and A15. Yeah, that's pretty normal. Okay, that's fine. So we're using D15 and A15 as the data and address registers to manipulate is fine, because that's what's being used in the higher up function. Okay. So what I'm going to do is go back and that looks good. Okay, cool. So this is going to be show 1000 RPM. Okay, then we're going to move the value of 1000 RPM into data register 15. Usually it'll be like 7D0, something like that. Okay, if I go to calculate, this is just like my experience, right? 7D0 is 2000 in decimal, but that's usually what like 1000 RPM is. And then to basically find out what it is in, to find out what like 2000 RPM is, we just times it by that, and then it's FAO. So right, so if we go move that into D15, but we also, what are we going to do? Let's actually store the value of 1 in this. If I go MOV D15, sorry, 1. Okay, then we want to store, yeah, we're going to have to do this again. That's okay. I'm just actually trying to reduce the amount of code that I have to write. Okay, then we're going to store byte D15, A15. D15. Is that going to work for us? Cool. Does that look good? Yes, it does. So we're storing the value of 0, because it'll be map 1, which is 0. We're storing that in our current map. And then now we're going to go MOV D15 7D0. Okay, fantastic. And then what we can do is we can return. All right, we can return. And then that can then store high there if we want to. You know what I mean? Like if we want to do something like that. But what I might do, I might actually do it straight from there, to be honest with you. So I'm going to go back down. Cool. I'm going to go MOV H.A A15 B000. Cool. And then I'm going to go LEA. Cool. Then I'm going to go store high. D15, A15, 0 times 0, D15. Cool. Now that should make sense. Cool. So we've got 0 is our map that's being stored into our map switch map in RAM, which is EEPROM, is RAM mirrored to the EEPROM, which then will save it when we turn the car off and we can start it up again. We're moving the value of 1000 RPM, which is 7D0, into D15, and then we're storing that high in the engine speed variable, and then when we're returning, okay, then I'm going to make this show 2000 RPM, right? So then we're going to go jump equals D15, 0 times 1, show 2000 RPM, like that. And what we're going to do is basically it's going to copy this a few times to go through, and then obviously I'll change the values in there, but we'll go 1, 2, 3. So that's going to be show 2000 RPM. It's going to be show 3000 RPM. That's going to be show 4000 RPM. All right, so we're going to go jump equals D15, 0 times 2, like that. And we're going to go jump equals D15, 0 times 3, like that. Oh, all right, making progress. It's full on, and I'll do this for like I'll do this for like maybe 5, 6, 7 hours a day. This sort of stuff. It's hectic. It's a lot of work, man. It's tiring, but it's good. I don't hate it. Definitely don't hate it. FAO. I think that'll be 1440. I gotta remember this stuff. I haven't done it in a while. 1F40. Sorry, 1F40. And then times. Is that actually, does that make sense? I don't think it does. That doesn't make sense. So we got 7D0 times 3, rather, 1770. And then plus 70, which is 1F40. There we go, that makes sense. Cool. Okay, so now we're going to go tip down. If it's map 1 and we're tipping down, we want it to go to map 4. So we're going to go like this. If it's map 0, we're going to go to map 4. Like that. Okay, if it's map 2 and we tip down, we want it to go to map 1. So we're going to go show like that. Okay, if it's map 3, Jesus Christ. I do this all the time to myself. If we go map 3 and we tip down, we want to go to show 2000 RPM, and map 4, we want to go show 3000 RPM. All right, it's starting to make a little bit more sense. Map 0, if we tip up, we want to go, or map 1, sorry, we tip up, we want to go show 2000 RPM. Map 2, we want to go show 3000 RPM. Map 3, we want to go show 4000 RPM. And map 4, we want to go show 1000 RPM for map 1. Okay, see how this is starting to make a lot of sense? I'm just going to clear and do that. Wicked. What's that? What are you doing? B625. Why is that? Why is that coming in? Okay. Cruise latch. That's why. So tip down, tip up. Where are we going with the cruise latch here? Show current map. That's what you want to do. It's always really important to go through your code and make sure that you're not jumping and executing code and doing things you shouldn't be, because you can brick the ECU and all sorts of other things. This looks good. It's well structured, you know, it makes sense. So tip up, again, if you want to comment it, I'm just doing it for the purpose of demonstration, right? Purpose, function information. We go purpose to change the value of map switch map if the cruise lever is tipped up or res plus. Okay. Now same here with this one. Tip down and then go res minus. Okay, just if you want to comment it, you don't have to, but I'm just doing it to show you guys. Information, purpose, to display the current selected map on the cluster. Okay, cool. And you can go through all the rest of it. We don't need to do that, but there you go. I'm just showing you how it all works. Okay. Now, the thing that we haven't done is our map switch exit function, which I have put here. I suppose we might need a little bit more space than that, if I'm honest with you. So we might bring that back up to here. Okay, map switch exit. Okay, we might get rid of this. And we might then do this. See, hopefully we haven't put it too far away. That looks okay. Let's see about this one though. Okay, that's fine. Cool. Okay, what we need to do when we leave the map switch exit function is we need to set our latch bar to 0. So I'm going to copy this. Put it up here. Okay, we're actually going to go 15, 0. And then we're going to go store byte A15 0 times 0 D15 like that. So what that's going to do is going to store the value of 0 into our latch variable because we are exiting the function, so we don't need to worry about that. I might also actually copy some of this code here. So this code like that. A15 B000 of H.A A15 times B000. Okay, and then I'm going to paste all of that code in there like it was the factory function. Okay, let's just have a look at this, make sure we've done it right. Load high A15. What's A15? Let's go back to here. A13, sorry. A13 is up here. Cool, so I might even need to put them in. I might need to. I think that would be wise if I did that. It would be the right thing to do. I'm just gonna put rep in there. So our current value of A13 is here. Where's A13 used after that? Okay, so it's changed. That's fine. That's okay. So A13 is this. It currently has that address. So what I'm going to do is I'm going to take that out. H.A A13. No, is it B001? Is that where we were? So look, D001 2A76. LEA, A13, like that. All right, now going back, load high, and then we'll do all this. Okay, so we go copy this, go to our map switch cluster function, paste this in here. Cool. Store high. Okay, A10. We might even need to get where A10 is. Load high A10. Let's have a look. A10. We might also not need to, but it's always good to just check. I'm looking for a load effective address, so LEA instruction, or I'm looking for a MOV high instruction. It might have been actually passed right at the top of this entire logic system here. Go right to the top. Okay. I'm not going to touch that. I'm just going to leave that as it is. We'll see how we go. Okay, I'm going to return, and then let's just change that to a not. Cool. All right, so I think we're going to be okay with that. There we go. So that's good. So that's our map switch exit. At least the cluster variable takes on the value of whatever the engine speed is. High res. Why are we getting this? 1.5. A13. I see. What we might need to do. D11. I haven't touched D11. I think we'll get away with this, but we'll see how we go. All right, so I'm going to just settle this to like that for now. And then I'm going to go back to our function here. I'm going to jump from, I think here. I think there. I might go, or even there. What's that? Yeah, that'll work. Okay, so if I go map switch. What's it? Cluster, multi-map cluster, sorry. Boom. And then when we come back, we're going to jump straight to here. That's what we're going to go. We're going to go jump to there. So basically, it's going to make all of this redundant. That's not going to mean anything. So what I might do, I might just zero that out. Cool. Let's do that cluster jump. Save. We're going to come into here. Let's go. Boom. Cool beans. Very exciting stuff. That's all done. Multimap cluster. We're coming in from where our hook is. Going to here, if the brake's not off, we're going to leave. It's going to store the value of D15 in there, and we're going to return. The return jumps back to where we called it from. It's going to execute the next instruction, and that's going to continue on with the program flow. So what I'll do here, I'll go output. I'm going to set it to there, and then what I'm going to do from here essentially is actually open the original file to bring in my downloads. Finish immediately. Connect the two software versions across. I'm going to go to my Multimap reference, and I'm going to go to my cluster, and I'm going to copy all that over. Save. Cluster only V1 Multimap. Cool. Oh shit. There we go. Close, delete. And what I might do as well, just for completeness, is something like tag. Okay. I might just go like here. I might go edit as text. Multimap by Josh and Laborde Motorsport. Like that. Create new version, no. And we'll see how that goes, hey? So checksum, no, bflash, boom, and then I can go ahead and upload that to my file service where I had been doing this file. So I go down to Volkswagen Amarok, where are you? There we go. And then I can go ahead and upload this there. Boom. Okay. And then he can go ahead and test that for me and then see how we go. Once the cluster's all working, then we can work on actually switching the different map tables and things like that. Yeah, I hope you guys enjoyed the video. I think we've gone over quite a few things. I forgot to put the chat up, but that's all good. What's going on here? YouTube is not. What are we not doing? I don't know what that says. But anyway, all good. Thanks, guys. Tune in tomorrow. I'm sure I'll be posting and doing a live recording tomorrow as well. But yeah.